In the last video, we went a really roundabout way of looking at whether this drug decreased people's blood pressure, right? Way back when, we could just compare two different means and say, was one bigger than the other? But that doesn't tell us everything. In the last video, we said, well, is the first mean significantly different than 90? And is the second mean significantly different from 90? That gives us some information. But let's use the dependent t-test to answer that question more directly. We want to know if before people took this drug, was their blood pressure higher than after they took the drug? Was there a significant difference between before and after? This is a dependent t-test because every single person in the study is giving us numbers for both of these variables. Okay, the before and the after variables come from all the same people. So it's dependent in that way. It's repeated measures because the same people got repeated measures. SPSS calls it a paired samples t-test, but just a lot of words to mean pretty much the same thing. So let's actually do it. Let's see how we can test whether this average before is different from this average after. To do so, we'll go up to the menu Analyze, down again to Compare Means, then to the Paired Samples t-test option. And when you open that up, you get this window here. Right, slightly different than before, because here on the left you still have all the variables in your study, but then here it's basically asking you to find the two variables that are paired together, right? Which are you comparing to one another? So I can go ahead and click before and move that over there, and then the next one is after. We could go on and do a whole bunch of pairs if you had a lot of different comparisons you wanted to draw, but for right now we're just going to do these ones, and that's all. Then all it's going to do is compare that to that and tell you how significant it is. So here are the outputs, and we can see what we already know from the last few videos, that 98 is the mean before, 88.598 is the mean afterward. Each of those have their own sets of standard deviations, blah, 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 n equals 50, etc., etc. But here's where the t-test part comes in. Okay, so this mean is the mean difference, right? Each person has before minus after. You can see here that that difference on average was 9.7. On average, people's blood pressure was reduced 9.704. This is the standard deviation around the mean differences. But here's what we care more about, the t-test. Here again, t is equal to 11.07. That's a pretty big t-value. Our degrees of freedom are still 49. It's still n minus 1. 50 minus 1 is 49. And our significance, our p-value, is very low, which means we reject the null hypothesis. The null hypothesis here is that there's no difference in blood pressure before versus after. But because our p-value is so small, it means that it's very unlikely that we would get a number this big as the difference if in reality this drug had no effect. If in reality there was no before versus after difference, it would be very unlikely that we'd see a difference this big. So we reject that null hypothesis, and here we have some evidence that there is a significant decrease in people's blood pressure before versus after taking part in this study, right? And we know this with a p is less than, in this case, 0.001, because it's so small, it won't even show us what the actual value is. So we know it's less than 0.001. And that's it. That's all you have to do a dependent t-test. Once again, you'll just go up to Analyze, Compare Means, Paired Samples t-test, and then throw those into the pairing. Okay, you can also, in the same way, rather than go one at a time, you could click one, hold the Shift key on the computer, and click the other one. That'll click them both at the same time, and you can put those over there together. That'll accomplish the same thing. And that's all that there is. I mean, in theory, you could compare age to before, but that doesn't make any sense at all. But let's see what happens if we just... Okay, it doesn't like that. It doesn't like that we had both of these in there. All right, fine. Let's do this. Let's see what the age versus before blood pressure looks like. Okay, that obviously negative 33 is the t-value for that one. That's huge, but obviously, because we're comparing two completely different things, 98 to 61. There's no reason to compare those, and yet we decided to, for no real reason other than to illustrate that SPSS doesn't care if what you're doing makes sense. It'll give you some answer. So it's up to you to know that you're doing things in a sensible way, and it's up to you to interpret your results in a smart, thoughtful manner. Okay, but that's all there is to a paired samples t-test, and that'll do it for this video.